There are a couple of techniques for solving a log equation. This equation has two logarithmic expressions, one on each side, one on the left, one on the right. So in that case, I'm going to want to write this. Actually, I'm going to want to exponentiate both sides of the equation. That way, I can utilize the inverse property, 4 to the log base 4, 4 to the log base 4, and it leaves me with a very simple linear equation to solve. If you look back at that equation logically, if the left side equals the right side, and they're both log base 4, the stuff in the parentheses must be equal or have the same value. So now we solve this equation. I'm going to subtract x from both sides. And subtract 17. Finally, divide by 7. And we get x equals -2, which may or may not be a solution. We have to check log equations for extraneous solutions. We have to make sure that when we plug in a -2, we are not taking the logarithm of anything, log base b of anything. That anything has to be positive. It cannot be 0 and it cannot be negative. So mentally plug the -2 in. -2 plus 3, that's okay. -16 plus 17, that's okay. Log base 4 of 1 equals log base 4 of 1. We can calculate log base 4 of 1. 0 equals 0. So we have a solution. The other technique for solving log equations, we've already seen. Here, this equation only has one logarithm equal to a whole number. So we could still exponentiate both sides, or you could write it in exponential form. I'm actually thinking, why not just exponentiate both sides instead of doing something different? That allows us to use inverses. Don't forget that you still have to calculate 4 squared. Subtract 3. And we have to check to make sure that we can plug that in correctly. 13 plus 3 is 16, and the log base 4 of 16 truly is equal to 2. The other technique I was going to mention that we used in the last unit ends up with the same result, but you would write this in exponential form. You would take base 4 to the second power equals the argument. And look at that, it's really the same equation. 4 squared is 16. Subtract 3, same solution. A couple of different methods.